Hey everybody, my name is Yurash Jovanovic and I'm here to talk to you about Ambisonics. My research began looking at spatial audio rendering techniques in order to improve upon the current technology available on the consumer market, primarily focusing on 5.1. So, 5.1 surround is highly dependent on speaker positioning. As you can see here on the right, the ITU 5.1 standard uh, demands or uh, indicates that there is a central speaker placed at 0 degrees, one placed at plus 30 degrees, one at negative 30 degrees, one at plus 110 degrees, and one at negative 110 degrees. You can see here, 2 is the sweet spot, which is defined by Peters et al. As the point where the combined wavefront generated by the loudspeaker in the production layout is coherent, or alternatively, where the listener is roughly equidistant from the radiators. So as you can see here, 2, they are equidistant from all of these loudspeakers. And at these positions 1 and 3, they're not, and they're going to suffer from significant degradations, such as image localization, which is the perceived location of a sound, image stability, which is the perceived location of a sound source, and width homogeny, which is the uniform distribution of sound. And these are all a result of the two localization cues, or two main localization cues, I should say. Intraoral level difference, which is different amplitudes, and then intraoral time difference, which is the different arrival times of sound sources. So therefore, in order to accommodate the real-world playback environment, there's need for a playback system where each of the audio systems or each of the audio channels are independent of loudspeaker placement and listening position. So this brings us to Ambisonics. Here is the B format right here. Ambisonics was originally invented in the 1970s by Michael Gerzon. It's a method of encoding audio signals to record or render 2 or 3-dimensional sound fields based on both acoustic and mathematical principles. Ambisonics decodes high-quality speaker, independent spatial image that happens to be more immersive than 5.1 due to a height Z channel, as you can see here on the top right. So, in order to dive further into this, the B format, Ambisonics in general is pre or post capture independent. And the B format pre-capture right here, as represented by microphones, has the central omnidirectional representing the W. Up here is the central position where a listener's head would be, and then a figure of 8 microphone placed vertically above and below, creating a front and rear facing direction, and then a left and right. And so, unfortunately, one of the problems with the B format is that it perfectly recreates the directionality, and any sounds that are not directly where the loudspeaker would be are tend to be blurry. And then also, it happens to recreate the image localization better than our ears can hear. So this creates a bounce back effect where it sounds like sounds are in 2 positions. And this is a result because of the localization, and then also the fact that all of the sounds are played back at the same time. So this brings us to the O format, which treats sound sources as as a sound field instead of a directional sound source. And so it also naturally degrades to the point of when computational power is used up, it equals the B format. So at its worst, it equals the B format. So looking at limitations and further research, there are some alternative methods, but both wave field synthesis and vector-based amplitude panning suffer from significantly worse problems, wave field synthesis being price, and vector-based amplitude panning really suffers from objects in motion. And so, ideally, a playback system would not contain a sweet spot. That would be ideal, but Ambisonics and all of these formats really do still. And then there's also specialized decoder, which is required to a playback Ambisonics, so that needs to be addressed, but that is much more reasonable than having an entire array of speakers, such as wave field synthesis. And yeah, that is my presentation. Here are some of my references. I hope you enjoyed it. Thank you.